Hello everyone, this is grade 6, module 6, lesson 16, problem set. Number 1 says, the box plot below summarizes the ages of the time of the award for leading actress and leading actor Academy Award winners. So we have best actor and best actress. So to help me out, I know that this is going to be males and this one will be females. So we have to answer some questions based around this. A says, based on the box plots, do you think it is harder for an older woman to win an Academy Award for Best Actress than it is for an older man to win a Best Actor award? Why or why not? You can take either side of this one as long as you have a good rationale or a good argument for it. I'm going to say that it, just for mine, it is harder for a female to win as they get older as opposed to a male, simply because if I look up here, I can see that there's my median for males, and I have half of the data at older than 40. Meaning, even if I look at the middle part of my data, my two quadrants, 2 and 3, so the middle half of the data is from late 30s to right around 50. If I look at the middle of the data for females, it's much younger ages, so late 20s to early 40s. So it's showing that it seems like younger women are winning Best Actress awards, and it seems like older men are winning Best Actor awards. So I think this data is showing that it is, to me. But you could be arguing the other side of it as well. So there's my explanation there, just showing that it seems like the males have a little bit easier of a time winning a Best Actor award because the data is showing that they're winning it as they're older, as opposed to females who win it when they're a little bit younger. So let's go to B. B says, the oldest female to win an Academy Award was Jessica Tandy in 1990 for Driving Miss Daisy. The oldest actor was Henry Fonda for On Golden Pond in 1982. How old were they when they won? How can you tell? Were they a lot older than most of the other winners? So this one, I can tell by looking up top, and I can see that the oldest female, or as it says, Jessica Tandy, was about 80. And I can see it right there at the very end of my box plot. And the oldest male was right here, and that's looks like 75 or 76. Since I don't have the information in front of me, other than the box plot, I can't really tell, but I can say that Jessica Tandy was 80. Henry Fonda, I'll say, is 76. And how can I tell is I'm looking at the maximum values on the box plot. And then to answer the last question, were they a lot older than most of the other winners? This question kind of goes back to the box plot, and it looks like there's a decent-sized stretch between them, a bigger stretch for Jessica Tandy than it is for Henry Fonda. I would say that they are much, I would say, older than most, because that's what it says, most of the other winners, simply because the middle or 3/4 of the winners are much lower on the age scale than these two actors, more so for the women than the men. But we also don't know how many people or where they were placed for this upper 25%. Meaning there could be dots or people who were right in here and not so much down the line because we don't see the individualized data. With a box plot, we only see our 5 data points. We don't see each individual age. So I would say yes, they are for most, just because of where the box, the center of the data, lies. It's much further away from them. But also, we don't have all of the data we need to answer that question. And there's my description right there. C says the 2013 winning actor was Daniel Day-Lewis for Lincoln. He was 55 years old at the time. What can you say about the percent of male award winners who were older than Daniel Day-Lewis when they won the Oscars? So let's go up and put 55 in. So it's going to be right about here. And it says, what can you say about the percentage of male award winners that were older? I would say less than 25% because remember, these can be broken apart. This is 25%. This little piece is 25%. This little piece is 25%. And then this huge one is 25%. So he's falling in between that last 25%. So I would say less than 25% are older than him. So that's what I'll put down below for C. So there's my description there. And then let's look at our last one. Use the information provided by the box plots to write a paragraph supporting or refuting the claim that fewer older actresses than actors win the Academy Awards. I'm going to leave this one to you, but just take a look at that stretch that we have from the, or where the fourth quartile starts, or the fourth quarter starts, and look at how the first 75% or first 3/4 of the data are in a small compacted area, and that last quarter is stretched out quite a bit. That'll help you with your discussion or your paragraph. So let's take a look over at page 2. Here we are on page 2, and let's start right in with question 2. The scores of 6th and 7th graders on a test about polygons and their characteristics are summarized in the box plots below. A says, in which grade did the students do best? And then we have to explain how we know. And I'm going to say 3/4 of the 7th grade students did better than half of the 6th grade students, meaning here is our 3/4 of the 7th graders. And notice that this part that starts the second quarter lines up with the halfway point of 6th graders. So it looks to me like more 7th grade students got the same score as only half of the 6th graders. So I'm going to say that 7th grade students did best because 3/4 of the 7th graders did better than half of the 6th grade. So there's my description there. Let's slide down a little bit and we'll get into B. Why do you think 2 of the data values for 7th grade are not part of the line segments? That's what those stars are. And I'm going to say that the highest and lowest scores, and that would be these, our 2 asterisks or our 2 stars there, we're pretty far away from the other scores, so they marked them separately. We could continue that line and reach out and touch them, but it's looking like they're just trying to show that they were much further out than this upper quarter, and this one was much lower than the rest of this lower quarter. So they're trying to say that those were really extreme maximum and minimum values. Let's take a look at C. How did the median scores for the 2 grades compare? Is this surprising? The median score for 7th grade is right there, and the median score for 8th grade is right there. To me, that's not really surprising because the 7th grade is higher than the median of 6th grade. It makes sense because if they're both answering questions or a test about polygons and their characteristics, I'm going to assume 7th graders are going to do better if 6th and 7th take the same test because they have an extra year of information and knowledge around that topic. So I'm going to slide down and put that in as my answer. So there it is there, and of course I got to add that that 7th graders should know more about the topic. Doesn't mean they always do, but that's kind of the thought around this. The last one, 2D, how do the interquartile ranges compare for the 2 grades? I'm not going to do the comparison there, but I will tell you, here is your one data point, and here's your second one. For 6th grade, those are your 2 quartiles, and then you'll subtract those. And for 7th grade, you'll look at that value, and then you can describe. And to me, it looks like 7th grade interquartile range is much smaller, meaning the students' scores are closer together. That could be it, meaning they're all getting, middle part of the data, they're all getting roughly similar scores, whereas 6th grade it's more spread out. So I guess I did answer that question, but you might want to find the IQRs for each of those so you can compare accurately with some data. So let's take a look at 3. A formula for the IQR could be written as quadrant 3 minus quadrant 1. Suppose you knew the IQR in quadrant 1. How could you find quadrant 3? Well, if you know the IQR, and I'll do a quick example. So if the IQR is 7, and we know quartile 1 is 10, I have to subtract something by 10 to get 7. So what I would do is solve this just like we did one-step algebra or algebraic equations. I would add 10 to get rid of this 10 on this side because I want to get what I'm looking for by itself. I want to isolate that. What I do to one side, I have to do to the other. So I could figure it out by solving for the missing. And when we did the inverse operation up above, or isolating the variable, the other way to find it is exactly what we have put in there. The IQR plus quadrant 1 will get us quadrant 3, and that's exactly what we did when we added quadrant 1 to the IQR. And that was my example I used for that one. So let's take a look quickly at 4. Consider the statement. Historically, the average length of service as Chief Justice on the Supreme Court has been less than 15 years. However, since 1969, the average length of service has increased. Use the data given in exercise 1 to answer the following questions. So you're going to have to go back and take a look at exercise 1, that data, to say whether you agree or disagree with the statement, and then explain your thinking. So take a look at the mean average and then the mean number of years since 1969, and then answer that part. And B says, would your answer change if you use the median number of years rather than the mean? So make sure you have the means figured out, and then you're going to have to go through and make sure that you identify the median, and you want to compare that median score with, or the median value with the mean value to solve that. Thanks for watching. Hope this helps, and good luck on the rest of your problem set.